Welcome to the fourth Toobit development video. This one covers versions 0.12 and 0.13. Here we introduce two major new features, a threading core and server injection. Server injection allows remote injection of data into the universe. The threading core enables multi-threading in the time ticker. Server injection is quite simple. Like other commands are /v or /r, /i is server injection. After that, it expects a string of values formatted much like a file system. Of course, it expects these values to be numeric, and they're separated by forward slashes. For example, let's say you wanted to send the values 321. You would simply type into the browser after the server and port /i 3/2/1. The first three values of the string are like the header. 3 indicates that you're going to inject a grid 3 by 3, so a total value of 9. 2 and 1 indicate the x and y coordinates where this grid will be inserted in the universe. So here it would expect 9 more values after 321. After the server receives it, it's put into a buffer. For now, the injection is actually handled in the time ticker. It's put right at the front of the loop. It can be turned on and off simply in the header. If you're not using injection, I recommend turning it off. Here we see it in action. You'll also notice the /v interface has been cleaned up a little. On the right is a 5x5 grid of checkboxes. Simply draw out what you want to inject, and then click Begin Draw. Then go over and click on the screen. Sorry, for now it only supports 5x5, and using the getString method is going to limit us, so it can't go much bigger anyways. Obviously, there'll be a proper binary injection client at some point. In this universe, I'm running Conway's Game of Life and drawing gliders. Gliders simply walk forward at an angle. It's really fun because when they bump into stuff, they often create explosions. The noise everywhere was actually created by just filling the universe completely and letting it progress towards death, a kind of default baseline after an active space has died out. It's what tends to remain. It never really falls all the way down to 0, it'll fall down to some kind of noisy jumble like this. Between modes of view and physics rules, there's almost infinite permutations and effects you could create. I also added a quick little noise injector. This simply allows you to inject blocks of noise of various sizes. This was an easy way to get around the size limitations of the grid system for now. I can simply inject large blocks to test effects. Later, instead of blocks, these could be, say, silhouettes of people obtained through OpenCV via camera, or music injected through filters. Here the physics have deviated from Conway's original rules. A few modifications have been made just to test different effects. It's quite fun interacting with the various physics systems like this. It's already showing great promise at ghost trails and fading effects. And here's how the threading works. First, you have your main loop in Toobit.c. If you have threading on, when you init space, it will spawn off several other threads. One called the edger thread and one called the master thread. The edger thread's job is to process all the cells around the edge of the universe. The master thread's job is to process everything else. If more threads are desired, then slave threads are added. Slave threads simply split up and share the central space of the universe with the master. When your main thread calls a time ticker function, it communicates with these threads via signals back and forth, essentially sending pulses progressing time one tick at a time, with everything kept in lockstep. This will be largely invisible. All you need to do is enable threading and use the threaded time ticker. Aside from these, you've probably also spawned a server thread, so in total you've got 5 threads going if you're using one slave. By the way, for now it only supports single slave mode, so in total we've got 5 threads, but only 2 of them are handling really significant load. Even with a grid only 100 by 100, the edger would only handle less than 4% of the total grid. So for now, it still can't quite max out a quad-core processor. Everything's on GitHub. Here's a quick little review of how to use it. In any version, you'll have the files toobit.h and toobit.c. These 2 files will often be the only ones that you need to modify. Aside from the other source files, there's also an HTML directory with templates in it. This is where the template for the view interface is. Key parts to remember in toobit.c is first define your universe. You also need physics rules. Here's 2 different sets. And then there's your main loop. You'll want to initialize space, set the pointer to your physics function, do some things like heat death, big bang, start up a server, and then you'll have your main time loop. Here you can do some stuff like insert noise, change values of space, do big bangs, and then progress time by a certain number of ticks, and maybe even out of sleep if you need to control the speed. Then in Toobit.h, there are 2 main areas you're going to want to look at. First, in the config, you can set the XY of space, and then there are a bunch of optionals you can turn on and off. There's still quite a bit of work to do on the fundamentals, but I do hope to get around to memory maps and acceleration soon enough. Regardless, it still runs at quite a decent speed. In the end, it's unlikely memory mapping and acceleration will be feasible for all types of effects, so it will keep its original design of optimization and acceleration while still actually running the function on every point in space. Memory mapping will be seen as an optional acceleration on top of that. Well, that's all for video 4. Stay tuned for video 5. Looks like I'm going to be stuck working in a warehouse outside of the city for the next week, so it'll be a couple weeks before I get around to posting another video probably. Hope you enjoyed. Be sure to check out my YouTube channel and subscribe.